The next thing we want to focus on is text summarization. Text summarization is a very useful thing. You can generate a short summary of a large piece of text automatically. Kind of useful if you have to read lots of papers for a class, or lots of text, books or whatever. You can just summarize them and hope for the best. So text summarization, really most of text summarization works on something called extraction-based summarization. And the idea there is to take the text and look for what sentences you consider important, and then report those sentences in your summary. It's not perfect, but that tends to, especially in structured documents, tends to work reasonably well. There are also certain advanced techniques called abstraction-based, which try to abstract knowledge from the document itself, but those are more complicated. We're going to focus only on extraction-based summarization over here. In a very naive sort of way, what you do is you identify the most frequent words in a piece of text and use those occurrences of those words in a sentence to decide whether the sentence is important or not. So if the word, let's say America, is used a lot inside a text, then what you can do is you could say, look at the sentences that say America, and those sentences become important. And if another second most important is God, then you look for God, and then the sentences that have both America and God in them become the more important ones, and they come out, and so on and so forth, right? So God bless America would be, in that kind of stuff there. So we got this. So what you want to do, of course, is import your stuff first. So we want to import word tokenize, sentence tokenize. We're going to import the distribution thing, which returns the frequency distribution of words. So that's kind of useful. We're going to import stop words, which is words that are unimportant, like and, the, and all that stuff. And we're going to import ordered dictionary, which is a special kind of dictionary. Remember, dictionaries in Python are not ordered, so they are not ordered at all. But you can force them to be ordered by importing ordered dictionary. We don't really need that actually, but it's there right now. Then we want to prep the text. So let's say your community data are raw. I'm just going to remove all the extra end of line characters from there. So we get a bunch of things here. Well, strip text is really, we don't need the other stuff there. I don't know why it's there. Maybe I use it later. Oh, I do use it later. Okay, so I'm setting candidate sentences to an empty set, and summary sentences to an empty list. So the summary will contain the summary, candidate sentences are candidate sentences, and the counts are the counts of each sentence in the thing. So we get essentially like a set candidate sentence X has 20 times or 20 occurrences of useful words. So the sentences that have the maximum number of useful words are the ones that will get included in our final analysis here. So what we do is we take strip text, which is the text without our \n's in them, and remove any stop words from it, and any words that are not words, that contain numbers and all that kind of stuff, we get rid of them, and we lowercase it all so that we don't have a case thing inside it. And I need to run this first. I haven't done this. Okay. So that does our words generation for us. And once we've done that, then we can construct our word frequencies and choose the most common n of those words here. So we use the frequency distribution to construct the word frequencies, and then choose the most common 20 of them, or whatever you want to choose. And we can print them. So let's take a look at that. So it tells us that I is 73, the 46, food 20. So our stop words hasn't worked very well, that's for sure. Brunch 20, good 19, place 15. These are the most common words in this sentence. So interesting. Okay. So we've lowercase them. We've done that. We can tokenize it and get a bunch of candidate sentences. So we take our strip text and we sentence tokenize it. So it figures out based on the punctuation where sentences start and end, and takes each sentence in that and makes a list out of it. And then for each candidate sentence, we create a dictionary here that says candidate sentence. This is the candidate sentence, and that's the lowercase version of it, right? So we've got here, it contains the sentence itself, and then contains the lowercase version of it. The reason for this is very straightforward. When we report our summary, when we compute our summary, we want to be using only lowercase letters. But when we report our summary, we want to report it with the original cases. Remember, we're extracting actual sentences from there. So we don't want like Colombia here to be lowercase and that. We want, or America, we want it to make meaningful sense to the reader with the proper punctuation in it. So this becomes our candidate sentences. So these are all the sentences that we have. Next thing we do is we take the candidate sentences. We have the long and short, which is really our uppercase, lowercase really, and then for in most frequent words. So most frequent words, let's recall what that looked like. Insert cell above. Most frequent words, if you recall, is each word with the frequency of the word. So there's a list of tuples here, and what we want to do is we want to extract from this the word and the frequency score of all the words. And if the if a word is in short, okay, so remember we have two loops here. The first loop is extracting this here, so it takes the sentence number 1 in long and short. We don't care about long for a second, but let's say the short, the lowercase form of the sentences here, and then we take each word and its frequency, and if each word, take a word, like say take coffee for example, if the word coffee is in this lowercase sentence, then we add its frequency score, which is 12, to count, okay, and then we take that count and set it equal to the candidate sentences counts.long, so that we now have the this should actually be here, right? This is in the wrong place. This should be here. Yeah. So we get the total count of the frequency score there, and we get our candidate sentence counts.long, which is, you might want to correct that in your thing here. For some reason this got messed up, because what we want to do is we want to compute this count, that is the total frequency score for every word that is in the sentence, and then throw that into the as our total count for that long thing. So at the end of this, we're going to get let's take a look at it. You know what, let me do this here. We can take a look at it, candidate sentence counts, and we can print that. So we get here, I have a degree from Colombia, and now I have to get one from America, is total of 92, Jeff Finger community 83, and we can see 15 minutes wait for the wait staff, 45 minutes before we got the wrong dish, 129. So we have the sentences, the uppercase version of the sentences with the counts of them. So all we need to do now actually is sort this by the count, and if we sort it by the count, then we can take the first n sentences, and that becomes our naive summary of this thing here. So we're going to use ordered dict for this. So ordered dict is going to sort our candidate sentence counts dictionary, and it's going to sort it based on x1, which is the second element, the number here, that's x1, right? x0 is that, and x1 is that, and make sure that it's sorted in descending order. Reverse equals true will make sure it's sorted in descending order, and we get the first 4 sentences. That's what this is. It's going to pull out the first 4 sentences, and that's our summary really, right? So we get this here. I've come here several times, blah blah, and that becomes our these 4 sentences, and it's really up to us how many sentences we want. And I guess the number of sentences depends upon the entire total proportion of sentences in the text, or how many sentences there are in the text. So this says I've come here for brunch. There are a lot of nice places in the city where you can get a very good breakfast of 1/3 to half less than community. Brunch with my wife after she found a good review and it did not disappoint. The beans were seasoned perfectly. Tortilla was fresh and soft, blah blah. So that's our summary really, right?